So we have this transformations reference sheet. It goes on page 47. There's not a little blank for you to write it in, but that's where it's going to go. So we can go ahead and write that on there somewhere. So this is just going to be an overall reference sheet. One thing you need to know about transformations is we use letters in there to describe things. And different people use different letters when they teach it. And I'm using different letters than I normally do when I teach it because from what I can tell from the AP stuff, they use a certain set of letters now with these transformations and then a different set of letters later when we transform trig functions. So it really doesn't matter what the letter is. We could use anything. It matters more where it is in the function because that's what tells you what's happening. So really the letters are kind of irrelevant. But if you feel like it's different than what you've seen in the past, maybe it is. But again, it doesn't matter. The transformation is the same. So we have two main types of transformations. We have rigid transformations. Those are going to be your reflections and your translations. That means we're just moving things around somehow, but we don't change the size or the shape. Non-rigid transformations, those are going to be your stretches and your compressions, which are dilations, which actually skew the shape one way or the other. Okay. So the first thing we're going to look at are translations, where you're shifting things around, but the words we're using are translations. Okay. So we have a function f of x, and if we're going to move it up and down first, that means we are affecting the y value, right? That's what's changing there. So f of x is our function. F of x also represents a y value. So if I have, this is my original function, and I'm going to shift it down, that means I am subtracting a value, which we're going to call k, lowercase k. Hard to tell with my handwriting, I know, but it's lowercase. If I'm going to go up, then it's going to be f of x plus k. Right. So those k values, those affect the y value. This is the f of x is the y value, and then we add or subtract something to it, and that's shifting it up or down. Make sense? If I'm going to shift something left or right, I'm affecting the x value, which means it's inside the parentheses of that function. One thing we need to remember about x is that he is a liar, right? Okay, so if your teacher's never told you that, x is a liar. Y does not lie because he's a nice guy, but x is a liar. So if I'm going to shift left, it is going to affect the x value. Left minus would make sense, right? Remember, x is a liar, so it'll be f of x plus, and we're going to use h here. If I'm going to shift to the right, then this is going to be f of x minus h. And here's where in the past, and if I had my choice, I'd be using c and d instead of h and k, but it really, like I said, it doesn't matter either way. It matters where it is and what's happening there. Okay? We all good so far? All right, good deal. Gael, you with us? All right, so then we have reflections. If I have a point here, and I'm going to reflect it across the x-axis, what changes about that point, the x value or the y value? The y value. So if I'm reflecting across the x-axis, I am changing the sign on y, which is f of x. If I have a point here and I reflect it across the y-axis, I am changing the x value. So that means it's going to be f of negative x. You change the sign on x, you reflect in y. You change the sign on y, you reflect in x. So I'm going to ask you questions like, does this negative sign affect the x or affect the y value? This negative right here in this one affects this negative sign affects the y value. That makes it a reflection in x. This here, this negative sign affects the x value. That's what makes it a reflection in the y-axis. Make sense? Because those are the questions you've got to ask yourself along the way. Is whatever happening, is it affecting the x or affecting the y value? And then that tells you what's happening next. Okay? So let's look at our dilations now. So dilations, you probably talked about them more as stretches and compressions, which is fine because that's what's happening and that describes it a little bit better. But the word dilation is what we're going to need to make sure is in our vocabulary and that we're using and that we understand when we see it, okay? So a vertical dilation could be a compression or a stretch. And if it's something happening vertically, it is affecting the y value, right? So whether it is a stretch or a compression, it is some number, which we're going to use a, and it'll be a times f of x, because that's my y value. And then we're going to talk about the different values of a. Okay. The main thing I need to know is that if I have that A is a dilation, a vertical dilation, basically. But if it's a compression, then we use the absolute value of A, and the reason we do that is because it could be like -5 times f of x. Well, that negative is a reflection. It's not affecting my dilation. So we look at just the absolute value of that. If that value is between 0 and 1, then it is a vertical compression. If the absolute value of A is greater than 1, then it's a stretch. But either way, it's a dilation, right? So the function will dilate vertically by a factor of the absolute value of A. If I have a horizontal dilation, that means I am multiplying something that's affecting x. So it would look like this. F of b times x. Look like that in both cases. Okay. But what do we know about x in general? What is he?
Liar.
A liar. Okay, so x is a liar. So when I look at the absolute value of b, it's a compression if b, the absolute value of b, is greater than 1. Because if that was 2 times x, that would look like it should be stretched, but it's really going to be compressed by a factor of 1/2. And it's a stretch if the absolute value of b is between 1 and 0. Because what's happening here is the function will dilate horizontally by a factor of 1 over the absolute value of b. It's the reciprocal. So if it's 2 times x, the dilation factor is 1/2. If it's 1/5 x, then the dilation factor is 5. It's always the reciprocal. Okay? We good? Because x is a liar, something we have to remember. Any questions at this point? All right, so flip it over. And this is just kind of a different way to look at everything. This right here shows you all the transformation rules together, like if it was all happening at once. But shows you horizontal translations, vertical translations, reflections, and whatnot. So if I have f of x plus h, I know that's a translation left h units. And if I have a point xy, then that becomes x minus h because I'm translating left, so I have to actually subtract numbers. But in the function notation, that's what we have there. Okay, so it's just kind of a different way to put it all together. All right, everybody okay with that? All right, so keep that handy. I'm going to give you your next set of notes here. All right, so this is going on page 48 when we're done. And I want you to look at these questions. Notice how 1 through 5, we have actual functions that are like cubic, square root, absolute value, and so forth. And then on 6 through 10, they're generic functions where f of x turns into a g of x. Okay, so we've got to understand how to look at these things in 2 different ways. And we are going to write these transformations. Now, we're going to ignore these directions. Most of the time, you'll ignore directions anyway, because I changed them on the assignment. I forgot to change them on the notes. We're not going to necessarily identify the parent function. We're going to talk about it, but we're not going to write it down. They don't all have parent functions anyway. We're really just going to worry about the transformations here and how to write them correctly and how to talk about them correctly. It is important if you have an actual function, like here, this is clearly a cubic function, right, that you understand what's happening to x and what's happening to y. I mean, obviously, we're substituting in an x value, and a ton of stuff happens, and then it spits out a y value. But you know, are we affecting x before we do the function? That's what we're looking at here. So since this is x cubed, it's just purely x cubed. That means nothing's happening to x before we cube it. When we look at number 2, we've got all this stuff going on underneath that square root. So something is happening to the x value before we actually take the square root. Does that make sense to you? So that's why I'm asking, does it affect x or does it affect y? If a transformation affects x, then it's happening before the actual function part, whatever that is, whether it's cubing it or taking the square root of it or the absolute value or whatever's happening here. So let's just talk about number 2. We'll start with number 1, but we look at number 2 here. The negative here and the -1, both of those things are affecting x because it happens before we take the square root. Make sense to you? That 2 affects y because it happens after we take the square root. Does it show up first? Yes. But in the order of operations, would we multiply 2 before we took the square root? No, right? You do all the stuff, you take the square root, then you multiply by 2. Like, that's how you do the order of operations. So we're talking about when I substitute it in and I do my order of operations, is it happening before the function happens or after? Okay? So when I look at number 1, I can see that I only have one transformation here, and that's the -4, right? Is that -4 affecting x or affecting y? Y, because it happens after the cube, right? Does that make sense to you? Gael, you with me? Okay, you with me? You with us? All right. So this means that this is a, and since if I'm adding or subtracting, what kind of transformation is this? Yes, but like, what's it called? What's happening? It's a translation. So this is a translation, which I cannot abbreviate because then it just looks like transformation. Translation. And then since it's -4, we're going down 4. Okay? Make sense? All right. Now let's look at number 2. How many transformations do we have? We have 1, 2, 3, right? So I'm going to have 1, 2, 3. I'm going to make sure I get them all. So we're going to write them down going from left to right so we don't miss anything. Plus, if we were going to graph these, you want them written down from left to right because that's the order you want to do them in. So that 2, does that affect x or y? Y. And when we multiply, what kind of transformation is that? What's it called? Okay, what's the overall word? It could be a stretch or a compression, a dilation. Okay, so that's the word we need to use. We have a dilation. Is this dilation vertical or horizontal? Vertical because it's affecting y. And what factor by what? By 2. Good, because y does not lie, right? Gael, you need to like stand up and do some jumping jacks or stand up in the back of the room. What needs to happen here? All right, so then that negative sign there. What happens when we multiply by a negative? Reflection, okay? So I have a reflection, and it's going to be a reflection across something. Now listen to my question here. Does this negative sign affect x or affect y? It affects x, so we are reflecting across what? Y. Very good. All right, and then I have that -1. If I'm adding and subtracting, what type of transformation is happening? Translation, okay, so translation in general. Does this translation affect x or y? X, what do we know about x in general? He's a liar, so which way are we going? Right one, very good. Okay, everybody good so far? Now, are you used to writing, like, instead of dilation, writing whether it's a stretch or a compression? Because I am, but dilation seems to be more what we need to go with. And actually, it makes it a little bit easier because then you don't have to determine if it's a stretch or a compression. I don't know. All right, so let's look at number 3. How many transformations do I have in number 3? 3. Very good. I have 3. I have the negative, the 1/4, and the 6th, right? So I have, or the 6th, rather. I'm going to make 3 little things so I don't mess them up here. This is a quadratic, okay, so got something squared there. That negative sign, if I'm multiplying by a negative, I know I'm going to reflect. So I'm going to reflect across something. Now, listen to my question. Does the negative sign affect x or affect y? It affects y, so we reflect across x. Good. Then we look at the 1/4. We are multiplying by a number, so what type of transformation do we have? Dilation. Does that 1/4, so I have a dilation, does that 1/4 affect x or y? X. Okay, so it's a dilation, and it affects x, which makes this horizontal. And it's fine to write that it's a horizontal dilation. I'm just writing it down in the order we're talking about it. It's a horizontal dilation. And what do we know about x? He's a liar, so what factor is this? 4. Good. 5, 4. Any questions at all? Is it a stretch or compression? That's a good question. Anybody want to? It's a stretch. It looks like a compression, but because the dilation has a factor of 4, it makes it a stretch. It's a very good question. Okay, we good with that? Then we have that plus 6. Does that affect X or Y? Y. So this is a translation up 6. Very good. We're good? All right, so I'm going to give you a minute or so. I want you, well, first of all, how many transformations are happening in number 4? 3. Okay? So I want to give you a second, and I want you to come up with what those 3 are. All right, so Elizabeth, does that 3 affect X or Y? X, okay. And because I'm multiplying, what type of transformation is it? Are you Elizabeth? Thank you, Elizabeth. Okay, is it dilation? Elizabeth, is it horizontal or vertical? Horizontal, and what would the factor be? 3. 1/3, good. Because X is a liar, liar. All right, good deal. What about the 5? Does it affect X or Y? X, okay. And what do we call this type of transformation? Translation, good. And which way am I going? Left. 5, very good. Y'all agree with that? Thank you. Any questions? All right. The 2, does it affect X or Y? Y, and what do we call this transformation? Translation, and which way are we going? Which way? Down 2? Good. Does Y lie? No, because he's a nice guy, right? All right. Any questions on that? We all good? All right. So let's look at number 5 together. How many transformations do we have here? 2. That 1/2 is being multiplied, so it is a dilation. Is it vertical or horizontal? Vertical. And the factor here would be what? 1/2, good. The 6 is a translation. And which way are we going? Right. Good. We go right to 6. All right. Any questions at all? All right, so notice the main difference between 5 and 6. 5, we can tell that is a quadratic function. In 6, we have no idea what kind of function it is. We just know that we took f of x, we did some stuff to it, and it turned into g of x, right? So this is a generic function that we're going to look at and still should be able to figure out what our transformations are. We have 1, 2, 3 transformations here. Okay, that negative sign means that this is a reflection across something, right? Now, does that negative sign affect X or Y? Y. So it goes across what? X. That 4 is being multiplied, so we know that it is a dilation. Is it horizontal or vertical? Horizontal, because it affects the X. Horizontal by a factor of what? 1/4. Okay, so is that a stretch or a compression? It's a compression. It looks like a stretch here, but it's a compression, right? And then that 3 has to be a translation. Which way? Up 3. I know this might seem a little repetitive, but it needs to be for some of us just to make sure that we're looking at all this correctly. Any questions at all whatsoever? All right. Then let's look at number 7. Ooh, goodness. Hang on. There we go. We have how many transformations here? 4. 1, 2, 3, 4, right? I got 4. Make sure I get them all. And doing them in order from left to right is really a good way to make sure you don't miss any also. So that negative means we have a reflection Okay, so listen to my question. A reflection across which axis? X. Okay. Any questions as to why? Is everybody good? Speak up if not. All right. Then we have that 4. We know that that's a dilation. Is that dilation vertical or horizontal? Vertical, because it affects y by a factor of what? 4. Good. Then the 1 and 2 are both being added, so they are both translations. So I'm going to write translation twice. Okay. And the 1, I'm translating which direction? Left. Because x is a liar, so I'm going left 1. And the 2 means I go up 2. Everybody good with that? Any questions at all? All right. 8. I've got 2 simple ones, so let's just get them down real quick. These are both translations, right? Translation. Translation. All right. So the 5 means I go which way? Right 5. And the 1 means I go down 1. Okay. Any questions at all? All right, then I'm going to give you a minute. I want you to do number 9. All right, so Sophia, the reflection across what? The y-axis. Y'all agree with that? Yes, because that affects the x because it happens inside that function. Thank you very much. Is this dilation vertical or horizontal? Vertical, why? Okay, but it's vertical or horizontal depending on whether it affects x or affects y. Does it affect x or affect y? X. So that makes it horizontal. And what would the factor be here? Okay, what do we know about x? He's a liar, so what should it be? 3. All right. So this 4 means I translate which direction? To the right 4. And the 7 means I do what? Up 7. Good. All right. Any questions at all? All right. Good deal. So let's do this last one together. How many transformations do I have here? 4. 1, 2, 3, 4. Okay. So that first one, that negative, means it is a reflection across, okay, across which axis? X-axis. Very good. That 3/2 means I have a dilation. Is that dilation vertical or horizontal? Vertical. By 3/2. Good. And that 3/2, is that going to be a stretch or a compression? A stretch, because it's greater than 1, even though it's a fraction, right? So the 3 and the 8 are both translations. So I'm going to write translation twice. All right. And then that 3 means I go which way? Left 3. And then the 8 means I go down 8. Thank you. All right. Any questions at all? Right? All of your basic transformations, we got to know which direction and what's happening. We good? Awesome.